So, what if an AI could remember everything you've ever told it? I'm not talking about just for a few pages, but across millions of words for its entire lifetime. Well, today we're going to dive into a pretty groundbreaking research paper that introduces a new AI architecture called Titans, and it's designed to do exactly that. This quote from way back in 1787, it totally nails the central challenge that AI is facing right now. To build a real lasting memory, it's not enough for an AI to just store data. It has to master the art of attention. And that, right there, is the core idea that sparked the creation of Titans. For years, AI has been kind of stuck between a rock and a hard place. On one side, you've got transformers, the T in GPT. They're absolutely incredible at understanding the relationships between words, but their memory is fixed and pretty limited. On the other side, you have recurrent models. Now, these guys can theoretically handle an infinite amount of text, but they have to keep compressing information, which means eventually they start forgetting the little details. It's this classic trade-off, right? Precision versus persistence. All right, so let's start with the current champions of the AI world, transformers. Because for all their power, they've got this fundamental memory problem that we really need to get our heads around. Okay, here's the heart of the issue. For a transformer to really understand context, every single new word has to be compared to every single word that came before it. This is what makes them so powerful. But as the text gets longer and longer, the number of these comparisons it explodes exponentially. And this creates what researchers call a memory wall. It just becomes computationally impossible to give transformers a truly long-term memory. So if our current AI models are basically hitting a wall, where do we look for a better design? Well, the answer, as it so often is to look at the most sophisticated information processor we know of, the human brain. And the key insight here is that our memory isn't just one big storage unit, like a hard drive. No, it's this incredibly complex system of interconnected parts. We've got our short-term memory for what's happening right now, a working memory for juggling ideas, and of course that vast long-term memory for everything else. Each part has its own job, but they're all working together all the time. And this leads to a really fascinating question. What if we just stopped trying to build one giant memory for an AI? What if, instead, we built a whole team of memory systems, kind of like our own? And that is precisely the idea behind the Titans architecture. It's not one single monolithic model, nope. It's a system of 3 specialized memory components, all working in perfect harmony. Let's break down these 3 pillars. First, you have the core. This uses that classic attention mechanism that we know from transformers. You can think of this as the AI's short-term memory, super precise but limited. Second, there's the long-term memory. This is a totally new thing that's constantly learning and storing information from the past. And third, you've got persistent memory, which holds fixed, task-specific knowledge, almost like a set of built-in instructions. And here's a look at how it all comes together. So, the core is processing the current information, right? And as it does, it's pulling in relevant memories from both the persistent and the long-term memory banks. Then, after it's done processing, the core decides what new, important information needs to get sent back to update that long-term memory. It's this continuous loop of retrieving, processing, and storing. Now, the real magic, the secret sauce, is in this long-term memory module. It's what's called a meta model, which basically means it's an AI that has learned how to learn. And just like us, it pays more attention to things that are surprising. Events that don't fit its expectations. An unexpected plot twist, a new piece of data, that's what triggers a stronger memory update. But here's something that's just as important as remembering. Knowing what to forget. To avoid getting totally overwhelmed, Titans actually has an adaptive forgetting mechanism. It's constantly pruning and clearing out less relevant stuff, keeping its long-term memory efficient and focused on what really matters. Okay, so the theory sounds great. It's elegant, it's brain-inspired, but does it actually work? Well, let's take a look at how Titans performed when it was put to the ultimate test against today's biggest and baddest AI models. This is what's known as the needle in a haystack test. It's simple but brutal. You hide one single specific sentence, the needle, inside a massive document of millions of words, the haystack. And then you ask the AI a question that it can only answer by finding that one sentence. It is a brutal, brutal test of an AI's effective memory. And the results are, well, they're really impressive.
In a standard test, you can see the Titans model, that's the brown line with the stars, going toe-to-toe with giants like GPT-4. Now, follow that line out to the right. See what happens as the text gets longer? Notice how the other lines just plummet, while the Titans line holds strong, degrading far, far more gracefully.
But wait, because here comes the knockout punch. When they fine-tune Titans for this specific task, it doesn't just compete, it absolutely dominates. That top brown line, that's Titans maintaining near-perfect accuracy as the Haystack grows to 10 million tokens. It is outperforming everything, and that includes systems that are using RAG, Retrieval Augmented Generation, which is a technique literally designed to help AIs find facts in big documents. Titans, all on its own, does it better. And the numbers just don't lie. On standard language modeling tasks, the Titans model gets a lower perplexity. That's a measure of how surprised a model is by the next word, so lower is way better. And it gets a higher average accuracy than other top-tier competitors, like Transformer++ and Mamba 2. Oh, and the efficiency gain? It's just as stark. With a traditional transformer, as the text gets longer, its processing speed basically falls off a cliff. But the Titans models? They maintain a near perfectly constant speed. They just don't slow down. So what does this all mean? Where does this leave us? I think it's fair to say we are at the dawn of a new era for AI, one that's going to be defined by long, persistent memory. And this really gets to the main takeaway. Titans isn't a breakthrough because it's bigger, it's a breakthrough because it's smarter. It represents a potential paradigm shift in how we build AI, moving away from just using brute force to scale up models and moving towards more elegant, bio-inspired architectural designs. And the possibilities here are just staggering. Imagine an AI that could analyze a company's entire financial history in one go, or a personal assistant that actually remembers every conversation you've ever had with it. Think about a scientific tool that could model the entire human genome to speed up discovery. This is the kind of stuff that long memory unlocks. Which leaves us with one final, pretty profound question to chew on. If an AI truly never forgets, what is the limit to what it could achieve?